Hello students, welcome back to our video classes, and this is Anik Ghosh with you, your chemistry teacher. And today we are going to just continue with the chapter we were going through so far, which is matters around a sphere. Now, today we are going to discuss about the separating techniques. In the last video, we were also doing that only. Okay, we have discussed about so many basic techniques of separations. Okay, all of them were the physical methods only to separate out the constituents of a mixture. Whether it is a true solution or it is a colloidal solution or it is a suspension, we can separate them out. So in the last video, we have discussed about centrifugation methods. We have discussed about the evaporation to dryness. We have discussed about the application of suitable solvent in the last question as well. So there were so many different types of methods that we have discussed in the last video. So I think you have understood all of it. So today we are just going to, go through the next part where we are going to discuss about some more separation techniques, but they are a little bit advanced. So today, the first thing is the magnetic separation. Now, after that, we are going to discuss about the separations with using separating funnels. Okay, this is another different type of tool you are using over here. Crystallization, a very different types of method. Distillation, fractional distillation, and chromatography. All of these methods are very useful, and where the students those are doing their PhDs in different types of like scientific institute, PhD institutes. Okay, there they use all of these techniques to separate out their yields, whatever they get. Okay, so we would go through all of them in today's class. Okay, so I want your 100% attention in this class because this is going to be very important for you. Okay, now the first thing today is the magnetic separation. So you can see in this picture over here, in this GIF over here, that there is a belt like structure. So first we just go through the definition. You can see this process separating components of mixtures by using magnets. Now if I just go through that line, the first thing that comes in my mind is, from this line only we can say there should be a mix. In this mixture there should be, if that is a mixture of A plus B, either A or B is paramagnetic, or I should say that that it is magnetic. Paramagnetic is also the same thing only. Okay, it is magnetic. Okay, like it responds in magnetic field. Okay, so let's just consider a mixture of iron and let's just take anything like mud or sludge or sulfur. Let's just take iron and sulfur, mixture of iron and sulfur. So how would you be able to separate them out? We know that iron is, iron respond to magnet, right? So now what happens is, the thing that you can see over here, the rolling thing that is there, you can see there is a belt, right? This is a belt. Now this thing over here, this thing is rolling, and apart from that, that has a magnet in it. Okay, so the speciality about it is when about these two things, okay, are there in this belt. Let's just consider the red one. The red one is iron, and the blue one over there is sulfur. Okay, then what is happening? You can see the red one is getting, when it is just going through, it's just look in this position. They are two of them where they were just together. Okay, and initially, but when they're falling, red is falling from here and the blue is falling from here. This is the pathway of the red one, this is the pathway of the blue one. So what is happening over here? Why are they doing that type of things? So actually the thing that is happening is red is a magnetic material. Okay, it responds to magnets. So for that reason, what is happening is, when it is just going through that roller, the roller being a magnet, it is attracting the red brick more, red particles more. Give me a moment. Well, okay, anyways, the thing is, the magnet what attracting the red particles more. For that reason, what happened is, you can see the red particle is facing more attraction. So for that reason, it is falling later. So the thing would happen is, if there is so much red particle and so much blue particles inside that, then the one heap of red particles would be there in this position, and another heap of the blue particles would be there in this position, isn't it? So this position is a thing that respond to magnet or magnetic material. Okay, fine. So this is how you can do magnetic separation. So this is mainly used in like extraction of ores. Okay, so extraction of metals from its ore. So the thing is, when we are trying to extract iron like objects, those are magnetically susceptible. So those type of object, for that reason only, for that type of metal only, we use this method of separation. Got it so far? Okay. Now the next method, is separating funnel. So you need to understand how the separating funnel looks like. So if I try to draw the entire setup, so there is a clamp over here. This tries to hold on. Let's try to draw it first. This is the face of the separating funnel. Okay, from where you are going to put solution. Looks like something like this. A glass. This is made up of glass only. A glassware. Okay, like that only. And here, very. Okay, it looks like this. Okay. Now this is a separating funnel. Okay, so we use a clamp to hold it. We use a clamp to hold it like vertically, like it is there, like this only. Okay. Now there is a stopcock over here. We call it a stopcock. Okay. Now, how does it operate? So let me just draw another beaker over here as well. So we have two beakers, beaker A and beaker B. Fine. Now, how would you do this? So first, we need to understand what are the particles those are getting separated through this process. So this is a separating funnel, and this is the entire separating funnel setup. Fine. So let's just try to understand what is happening over here. So the thing is, you can see over here, used in liquid extraction to separate the components of a mixture into two immiscible solvent. So the thing is, when two immiscible liquids, so like oil and water, let's consider oil and water. These two are immiscible liquids. When they're mixed together, and if you just want to try to separate them out, so what you have to do is you can use the separating funnel. Now, how is it operated? So the thing is, oil does not mix in water. Okay. And if you just take some oil water mixture, then what would happen? Oil would float, right? Oil would float. So the water layer would be at the down and the oil layer would be on the top. So let's just try to draw this. So if this is the layer of water, okay. If this is the layer of the water, then the layer of the oil would be something like this, just over it. So these are the two layers. Okay, one is water, another is oil. So the layer which is more dense should be there towards the bottom. Okay, and the layer which is lighter should be there on the top. Now the thing is, now what would happen? So if this is the water layer and that one is the oil layer, then what would happen? So the first thing is, when you just mix them up and put them into separating funnel, they would get separated like that only. So the lower part would be the water and the upper part would be the oil, and they would be separated like that only. Now the thing is very simple. Now what you have to do is you just have to turn this on. If you turn this on, what would happen? The entire water would fall into a beaker A, right? Now now try to imagine this, okay? You just try to imagine this. So there would be a time when this entire blue part would get vanished. Okay. Now, after a moment, the picture would be looking like this, isn't it? Just give me a moment. Picture would be like this. So there would be the blue part over here. The water would be just up to this level, maybe. Just consider a situation where the water is here and the oil is about to come. The oil is about to come. The layer of the oil about to come at this position. Now this is about to come and the entire water is falling, so the air is about to come towards the stop cork, and now I'm going to stop it. When the layer of oil is just about to come through that funnel, I'm just going to stop the stop cork now. Now I would put this out and I would take the beaker B and I would put the entire oil into beaker B now. So in this way, I would be able to separate out the mixture of A and B. Isn't it cool? So this is a very simple method, isn't it? One more thing. This is worth mentioning. So it comes up with a rubber, or we should say with that is mainly glass made. Okay, the entire thing is borosil glass made. So that comes up with a cap on it. When you are doing this experiment, you need to put this cap aside, because without the pressure of the atmosphere, this thing would not go to the beaker. Okay, if you just open your stopcock, that would not go to the beaker. So you need to open the lid to let the air in, so that the pressure would be there. Only then this experiment would be fruitful. Okay, clear? So that was the process through which you can separate them out. Got it? So oil and water. You can also separate out benzene and water. They are also immiscible. Benzene and water, because benzene is organic substance, whereas water is inorganic substance. So for that reason, what happens is benzene water is immiscible. Organic and inorganic doesn't mix at all, because that water is a polar substance. You can also say like that only, that this water over here, this is a polar substance, whereas this benzene over here, this is a non-polar substance, isn't it? So polar substance cannot dissolve non-polar substances. Okay, only non-polar substance can dissolve it. So there would be a distinct layer in between them, and you'd be able to separate them with the help of separating funnel. Okay, got this thing clear? Very simple, isn't it? Now, what is crystallization? So crystallization is a technique we use to purify the solids. So just let me tell you how this crystallization occurs. It's a very simple method. Okay, the thing is, when you take a solution, take a beaker. Okay, just think about it. You're just taking a beaker, and after that, in there, you have taken water and copper sulfate. So you have taken copper sulfate and water. So what would be the color of the solution? The color of the solution would be something like this. Fine. Now let's just consider this copper sulfate contains some impurities. Let's just consider that it contains some impurities. Impurities like anything, like sand, a little bit sand, silicon dioxide in it. So sand particles would be also dissolved in here. Fine. The impurities. This is there as an impurity. Okay. Now the sand particles would be also there, right? This would be also there. Now the thing is, if you just try to crystallize it, now how would you be trying? How would you be able to crystallize it? So first, what you need to do is you need to heat this object first. Okay, you need to heat this object first, and you need to keep on dissolving copper sulfate in it unless it gets saturated in the elevated temperature. So you need to make it a saturated solution in elevated temperature. You need to do that first. Saturated solution, elevated temperature. Okay, you have made it. Now after that, the second step is you need to cool it down. Fine, you need to cool it down. This is the first step, and this is the second step. If you do this thing simultaneously, what would happen? First thing is a solution is saturated in elevated temperature. If you cool it down, what would happen? The solubility, what would happen to the solubility? When you decrease the temperature for a salt solution, what would happen? For a salt solution like copper sulfate, what would happen? If you decrease the temperature, then the solubility would, tell me, solubility is decrease, right? Decrease the temperature, solubility decrease. If you increase the temperature, solubility will increase. What happens if you just try to dissolve some sugar in a normal water and a hot water? Normal water would dissolve less amount of sugar. Hot water would be able to dissolve more amount of sugar, right? So that is the same thing happening over here. So when you're trying to heat it, it is dissolving more amount of copper sulfate, and now you're trying to cool it. Then when you are trying to cool it, the solubility is decreasing. Now the excess amount of copper sulfate that you have dissolved in the elevated temperature, that is going to get settled down in the bottom of the beaker, isn't it? The excess amount of copper sulfate that you have used, that is going to get settled down in the bottom of the beaker as the crystals. So that is called the crystallization technique. That is called the crystallization technique. Silica won't take part in this crystallization, because crystallization occurs for the pure substances only. So when it would get crystallized again, so that would be the copper sulfate only, not the silicon dioxide, not the silica, not the sand. It would be there as an impurity in the beaker. So in the crystallization process, you can find out the most purest reagents through crystallizations. Fine. So let's just watch this video now. Getting it? All the things. It's very simple, isn't it? Now, so you can see everything, right? The food taste will be because of the salt. You can see everything, right? You don't know this. You don't need this sound. So they are trying to teach you about crystallization, that in the way that how this salt is obtained in that way. Okay, salt is obtained through crystallization only. Let's see. Salt is obtained by the evaporation of seawater. However, this salt is impure and has small crystals in it. The salt can be converted into pure state by the process of crystallization. Right? Crystallization is a process formation of large crystals in pure state from their solution. You got that point? The solution is going to get evaporated and the residue is going to make the crystals. It's giving bribe, isn't it? If you ask me, I will give you reward. Get me some water. Take some water. You can do that as well. You can do crystallization at your home. Take some water in a container, heat it like I told you. Now dissolve. The water started boiling. Now the temperature is higher now. Now you are he's just dissolving salt in it. Keep on dissolving salt in it. Unless and until it becomes saturated. I think you're well aware with the word saturated, isn't it? Saturated. It was there in the last video. Okay. So it until and unless it can attain the maximum, the water can attain the maximum limit to which it can dissolve, right? Stir it, make it dissolve. Keep on adding it. You need to make it saturated. So until and unless it is stop getting solubilized, you just keep on giving it. After you have taken it, filter it, okay, whatever, because you need to remove the impurities. If you just filter it, the impurities won't get removed, right? After a while, so you there to make it cool, right? To cool it down. So if you just cool it down, what would happen? Okay. Now they have taken a string to get the crystals better. They're tying it, just putting it there, the string over there. Okay. If you do the same thing, you'll be able to see the crystals as well. You just need to cool it, okay? They are just over exaggerated it. So you would be able to see the crystals. That is nothing but the residue. Okay. When it is just cooling down, the residue is the crystals. Okay. So I think you got these points about the crystallization. So only the pure things are going to get crystallized. All the impurities, they are going to get settled down. Okay, fine. Now we have moved into the distillation process. This is a very important process. Okay. Now, how to understand what distillation is? So distillation is a process involving the conversion of liquid into vapors that is subsequently condensed back into liquid form. Now, look into it. Let's say we have a mixture of A and B. Fine. Let's say A has a boiling point. The boiling points are, let's say it is near about 25 degrees centigrade. And for B, the boiling point is, let's say it is 75 degrees centigrade, something like that. Now, if you just if you just take a beaker, okay, I'm just making it simpler for you. We would go to the entire process through it. Okay, so if you just take a beaker, just wait for a moment. Yeah, and after that, if you just take the mixture of A and B in it, if you just take the mixture of, so let's just consider that this is a mixture of A and B. Okay, now if you are heating this mixture, if you are heating this mixture, okay, now you're heating it, and you have taken precautions that the entire thing is connected to something that cools down, whatever comes in it. So what would happen when you start heating it? When the temperature is reaching to 25 degrees centigrade, is same like the evaporation only. Okay, so when it start when it's having the temperature 25 degrees centigrade, what would happen? The entire the solution of the A solution would get evaporated, right? When it would get evaporated and it would get to this part is cold. Okay, it would get evaporated, and when it would reach this part, it would be cooler now, so it would again form that liquid. Now if I just put a pipe over here, then after reaching this part, when it would get again, it would form liquid, then only the A liquid would fall from this. Only the A liquid would go from here. Okay, got my point? So mixture of A and B is there. I am heating it. Okay, only A is getting evaporated first. Okay, only A is getting evaporated first. After that, what is happening? After that, I am cooling it down after a certain height. After a certain height, I am just cooling it down. So when I'm cooling it down, what would happen? That it would cool down like the liquid. When it would get cooled down, it would again form this liquid. Okay, and it would just slide through another pipeline over here. If I just put that pipeline in proper position, it would slide through that pipeline. And after that, if I just take a beaker over here, I would be able to take that A, and B would be there only because the temperature is not 75 yet. Yeah, I need to keep that in mind, that temperature doesn't reach 75 degrees. Then B would also start evaporating. Then again, the mixture would be there. Okay, so this was the entire overview about this. So it was rather a very shallow discussion. So let's see what is the exact thing. Oh yeah, that was the very important thing over here. Okay, as the previous one was about the immiscible liquids, but distillation happens for the miscible liquids, occurs for the miscible liquids. Okay, so the miscible liquids, for them only we use the distillation process, not for the immiscible. For immiscible we use separating funnel. For miscible we use this. You can see this is the entire setup. You can see the setup is pretty impressive. Process of separating miscible components of a mixture that do not decompose upon boiling and have a sufficient difference between their boiling point, like I saw you. So you can see this is just heating it. Okay, and let me show you again. So yeah, over here, if I just stopped it, you can see here it is heating it. Okay, it is heating it first. After that, the entire gases are going out. What are the gases? The gases are of A only. Okay, because the temperature is 25 degrees. Let's say 25. So after that, it is the pipeline through which the gas would come out. And here what would happen is, here this thing would make it cooler. Let me show you. So here it comes, And in that position over here, okay, over here, we call it column. Now this column has a speciality. Can you see that two, there are two pipelines over here? So from this pipeline, these two pipelines, constantly the water is flowing. So water is flowing from that pipeline and it is going through this pipeline. Getting it is an outlet. So let me show you how it looks like. So there is mainly a glass container, okay? There is nothing but a glass container. And in this glass container, there is an inlet and there is an outlet as well. Okay. But the thing is, the pipe through which the gas was going, that has nothing to do with it because the pipe goes like this. It goes like this through it. It has another layer. Now what happens is the water gets in, okay, and it just remains over here, but it cannot touch the what is there inside this pipe. It cannot touch anything inside this pipe. So you can see there are two pipelines over here as well. You can just compare both of them. So water comes in from here, goes out from here, but whatever is there inside that pipeline, inside this pipeline, cannot be touched. Whatever there inside this pipeline cannot be touched, okay, through with water. So this part is mainly doing the work of cooling down. Okay, doing the work of cooling down. So when it would cool down, this gas would go through it and cool down. What would happen? It would just fall like another liquid. So this is what happens. Fine. Very simple. So this is an example where we use this distillation. So example, to separate acetone and water. So acetone is just a spirit, okay? Acetone and water. So acetone is a spirit. So spirits has very low boiling point, right? So if you just mix them together, that is a miscible solution. That's the miscible solution. So if you just do this fractionating column method, so if you just heat it, what would happen is the acetone would get evaporated, not the water. So the acetone would get evaporated, okay, and it would get go through that column and get into another beaker. Right? That is the process over here. For a moment. Yeah, so almost one of the most important and almost the last video as well, you can say. Let me just see it. Yeah, it would take a couple of minutes, so we would just look into it. The process of separating a substance into its parts, taking advantage of different vapor pressure and the properties of those substances. So what is the difference between fractional distillation and a normal distillation? Why do we use this fractional distillation now? Why is it coming into the picture? So in the previous example, A had the boiling point of 25 degrees centigrade and B has the boiling point of 75 degrees centigrade, isn't it? This was the previous picture. But if the A and B, both of them, has very close boiling points, 25 and 30 degrees centigrade. So basically within 25 degrees centigrade. Within 25 degrees centigrade. So difference within 25 degrees. So difference. So when the difference is within 25 degrees centigrade, then what can happen? Just check it. Yeah. Yeah. So the thing is, when the temperature is about 25 degrees centigrade, then what can we do? Now, if we heat it, if we heat object A, B would also get heated a little. And that process is not applicable anymore. Okay. So we need to think about something else. So that is the fractional distillation. Let's see. Let's take an example. So this time they're taking an example of acetone and benzene. So 24 Kelvin, isn't it? The difference? Acetone and benzene has a difference of 24 Kelvin. So what would happen if I just mix acetone and benzene, or if I just heat it? Okay, one more thing, that is the thing from coming out from here in this video only, that condenser over here. Let me just show you. So this thing over here, the condenser, that is mainly cooling it down, we call it condenser, and it is called Liebig's water condenser. Okay, and this thing over here is called the fractionating column. Okay. So how does it work? So there is a distillating column, right? Or fractionating column, you can also say. Okay. It is attached with the round bottom flask. Okay. This is the picture. So when you are heating it, the solution, when you are heating it, what is happening? It's going up, going up. When the mixture of A and B goes up, at this position, okay, at this position, okay, you are heating it, right? The temperature is maximum at this position, okay? So the gas, so just say A and B are there, and let's say A has temperature here about 30 degrees centigrade, and this has 34 degrees centigrade, boiling point, okay? Now, if you just heat it, okay, up to here, that would be 30, let's say that is 30 degrees centigrade, then what would happen? So after coming over here, what would happen is the A would become, after 30 degrees centigrade, the A would become liquid. Okay. Look, all of them are gas now because the temperature is near about 80 degrees centigrade. Let's consider all of them are gas now. Now, after going there, A would become liquid, isn't it? Because the temperature is decreasing on that position. So A, that is having the lower boiling point, that would again become liquid, and that would fall into that beaker. And that is having the element having more boiling point, that is going up and going through this fractionating column over here. Okay, that is what happening over here. So in that way, they are getting separated. Fine. And the last process is called chromatography. So chromatography is a very simple process and is a very fundamental process, I should rather say. Chromatography is used to separate different components in a liquid mixture. So mainly, what happens is, let's see this video. Watch this video first. After that, we would come back and I would just try to explain what is chromatography, what chromatography is actually. So chromatography is a very simple method. So the thing is, if you just consider you have an ink, okay, you have the ink. Okay, this ink is made up of, let's say, red particles, let's say blue particles, and black. Okay, let's just consider I have a mixture of these. Okay, now what I'm doing is I'm just putting all of them. Okay, I'm just putting all of them in a beaker together. Okay, now after that, I'm just taking some water. Okay, now if I just dissolve, if I just put a filter paper over here, what would happen? All this red, blue, and black, all this color would start getting soaked in, and they would, start traveling upward. Okay, they would start traveling up. Let's see the video. The goal of this experiment is to separate out the different pigments of ink of this marker. Okay, so whatever they are taking a marker. That is the thing. That is nothing but a filter paper where a line is drawn. Okay, so you can see how that just goes up, and that thing has the ink. Okay, so when it just rises up, the colors are getting separated. You can see. Exactly. So you can see what is happening over here. What happens is, in the pigments of water, these pigments of water has different solubility. Let's say red is highly soluble. Okay, and blue is less soluble, and black is less soluble. Let's say black is less soluble in water. Then what would happen? In this paper, in this filter paper, the thing that is highly soluble, in water, what would happen to that? That would go upwards. That would go more and more upward. And the thing that is lower soluble with water, that would remain at the bottom. In that way, you can separate out the components of ink. And you'll be able to see in this blue pen what are the colors mixed together to make that blue pen. Wait for a moment. Something's wrong, I guess. Yeah, just wait for a moment. Completed all of it. It was done as well. Yeah, that was done as well. This video was done as well. So let's go to the questions, the FAQs. What type of mixtures are separated by the technique of crystallization? So in what type of separation technique is crystallization? You can see the technique of crystallization is used to separate a solid from a liquid solution. Okay, it is linked to precipitation. So the thing is, when a solution is when there is a solution of copper sulfate, as I told you, there are some silica in it. There is some silica in it. What would happen? Like you can see, that is called crystallization. That would happen. Okay, so to maintain high level of purity, this crystallization is used. Okay, now what is the basis of principle of chromatography? So we say differential adsorption. Okay, chromatography is the differential adsorption. So you can see it is based on the differential migration or adsorption, same thing. of the individual components of a mixture through a stationary phase influenced by a moving phase. So what happens is there are two types of phase. One is stationary phase, another is mobile phase. Okay. So as they have differential migrations, that would happen. What would happen is mobile phase is the water that is, coming up. Okay, and stationary phase is the filter paper that is there. Okay, that is what they are trying to tell you. Okay, so that's it. I guess that's it, and we have completed another lecture video as well. And congratulations to you as well that you are continuing with all is this videos. So definitely I think if you are watching my videos from the very beginning, I think you have understood all of it, and they're very simple, isn't it? If you have any doubt, you're just going to write it on our forum, and one of us was definitely going to meet you there. Okay, that's it for today, and I think you would be watching my videos further as well. Okay, and you would be keep on practicing it. Okay, thank you for your attention, and keep learning from Ask IITians. Bye everyone.